Malbec.
And
what?
And we're here.
Oh.
Wait.
Hello.
Oh, and.
Hello, and welcome to the World Sand Project. I am the magical sand princess and life coach to the rich and famous, Shelley Carney.
And I am the sand administrative assistant to the magical sand princess. And I have some good news and I have some bad news. The good news is we're going to learn something. The bad news is, oh my God. One of our viewers said that every time they hear this song, they just want to start doing a calypso kind of dance. Yeah.
That's why we play happy music, so
exactly.
we'll be happy.
All right, let's get a show on the road here. I hope you guys can hear that. It indicated on here that you couldn't, and I'm not sure why. Tony sure has picked up on that tuna thing.
Sandwich. Get it?
Sandwich.
Sand.
The tuna sandwich is there. Okay, so first of all, of course, as usual, we have to sing Old Lang Syne.
What was that about?
Housekeeping, you want towels?
Well, of course you want towels. Make sure that before you leave today's video, you like it, because the Magical Sand Princess likes it when you like our videos. In addition to that, share it with your family, your friends, your neighbors, your business associates, the entirety of your social networks, and that way we can
Grow the channel.
And finally, was like the Bible school version. And then finally, if you're not already a subscriber, this would be the ideal time to subscribe by clicking on that subscribe button. Oogaing that subscribe button. And when you see the notifications bell pop up, bang that notifications bell. And that way, when we start a live stream or when we schedule a live stream, you'll be immediately informed and
in the know.
Because you know what? We've discovered in life there's nothing being better than being in the know.
In the know. Or the yes.
So just for being in the know. So let's talk a little bit of chemistry here for just a second. So up until this point, we've had a bunch of sand samples that primarily consisted of silicon and oxygen, silicon oxide, and that's what turns into the graminet. This one is a completely different sand sample. It is gypsum, and gypsum is not made primarily from silicon. It's made primarily from calcium with a little bit of silicon, a little bit of oxygen thrown in, and sometimes there's a water molecule added to it. As a result, this sand, the sand that we're going to see today, would never have made it. And the reason this is important, so let me back up. Take a deep breath, Toby. So I have told you in the past that we are using sand as a natural resource faster than our lovely dear Mother Earth has the ability to replenish it. And it is primarily used in three ways, and I'll characterize them in the following. Number one, construction, mostly in combination with cement to make concrete, to make everything else, including the house that's around you right away. The second use of it is in industrial, and I'll include in there everything from glass, the windows that are in your house, to bottle making, to the silicon chips that are in your smartphone that you're probably holding right now. And then the third use of it, and this is the one that's used mostly by countries in the Mideast and the Far East, is land reclamation, pouring sands into the oceans to reclaim some of those oceans, turn them into land, and then use them to accommodate their population. You know what? I'm going to lower our camera just a little bit because it looks a little high.
Yes.
There we go.
I think that's better.
Sitting way down.
Yeah, we're like little shrimpies.
Yeah, little shrimpy people. So those are the three uses of it, and sand is required. And you've also heard me say in the past that it's you can't use desert sand because in most cases it's too fine and it's too rounded. It doesn't hold together well enough for any of those things. This is completely different. The sands that we're going to talk about are gypsum. And while they can be used for some things, like it is used, for example, in I always forget that stuff's name. It's wallboard, wall stuff that you make walls with. What is that called? Drywall. Yeah, drywall. So it's used very consistently in drywall, and it's very good for that. It's not required to be hardened, for example. On the Mohs scale, which is the scale that's used to determine the hardness of various minerals, the quartz that we've seen in the recent past is 7 to 7.5. The stuff that we're going to see today is 1.5 to 2. So even if it were to travel in the same routes that most sand does, that is down a mountain and into a river and then along a river all the way to the ocean, it would never survive it. The calcium would break down, releasing the silicon. The silicon is just molecules rather than anything of significant size, and the oxygen would go into the air. So it would never actually survive. So the good news is it does have a purpose, and what we're looking today is a very beautiful location. And it struck me as funny because people are always talking about, well, you can walk along a beach, and you go like, oh, this is a pretty beach, not realizing that what you're walking on is even more beautiful when you look at it under a microscope. Here's the bad news. This is one of those locations that when you look at it while you're standing on it, it's really a beautiful and unique location. When you look at it under a microscope with a very expensive digital camera fitted on top of the microscope, they hate it. And it's not very pretty under the microscope, but we're going to go ahead because this is a valuable lesson learned for me. And the lesson learned is if I want to keep this interesting for you guys, I should check out my sand sample before telling you what I'm going to do the next program. So from now on, I'm not going to predict what we're doing the next program because that was probably the mistake that I made in all of this. So I'm going to swing over to the window shot and... Holly, thank you. It's my birthday today. I'm, how does Davio say it? I have traveled around the sun 71 times.
Fun.
Yeah.
Wee.
Okay, so what we're going to be talking
about. You don't know
about.
how fast you're going.
No,
really.
you don't. 66,000 miles an hour.
Yeah.
When you combine all of it. So we're going to be talking
the sand
about
isn't just flying
all over. Yeah. And if it wasn't for Newton, it would be. Good thing he told us.
Yeah.
What we're going to be looking at today is white sands. Up until recently, as Shelley noted in one of our videos, it was a national monument, and recently it changed the what is it? It's not Department of Agriculture. Department of Interior, converted over at the request of one of our senators to a national park.
Yes.
And I've put all of these links in the description box below, including this link to the National Park Service website for the White Sands National Monument. White Sands is also very special to New Mexico, so New Mexico True has its own website for it. So I put that link in there. And then I added a video. This is a copyright-free video that was produced by New Mexico State University, which is where my sister went to school, and it's on on the biology, the bioecological characteristics of White Sands National Monument, and I added that to, I couldn't, since it's a single video, I couldn't put it in a playlist, but it is uploaded to our channel, and I put that link in the description box below. So let's get on to the nitty gritty here. So,
gritty.
Actually, should I start with pictures?
I'm not going to play the ocean sounds today.
Not yet. No, there's no ocean. Got no oceans. Let's look at pictures first. I do want to remind you we have a special gift for you today. I don't know why Google Photos always shows the less one low resolution. So what we have for you today is I took a sample of the white sands and I put it in this.
They can't see.
They can't see it. Okay, hang on.
They could see the big picture.
Right. Well, you can see the big picture, but let me just do this real quick. So I took a sample of the white sands and put it in this glass pendant, I guess is the best way to describe it. It's sealed, so the sand will never spill out. And I've put that little device on it so in case you wanted to have a jeweler stamp or engrave your initials on it. And we're going to give that away next Wednesday because I need to get back to the Wednesday things. Oh, wow. That is really neat.
Yeah.
I'm going to get some of those.
Yeah.
You can't see it, but Shelley has a heart that says, hey, Shelley says,
I have a heart.
Yeah, you have a heart. Thank God.
On my wrist.
Thank God you have a heart on your wrist. She's wearing her heart on her wrist.
That's
So we put that
bracelet I got from
together,
Lisa
and
Smith.
it contains sand from White Sands National Monument, and we're going to give it away next Wednesday. I wanted to inform you, Shelley and I talked about this yesterday, and what she suggested is that when we do giveaways on Wednesdays, we should give you the option of the picture or the pendant. But I wanted to announce this and get in line next Wednesday so that we'll give you the option for next Wednesday of the picture or the pendant. But we'll have two different drawings on Wednesday, one for the picture and one for the pendant, and then they'll be together.
What did they have to do to win?
Okay, so what you have to do to win is make a comment on today's video. All right? After the video is published, make a comment. And
since you guys are all saying happy birthday to Toby, maybe you could write that in the comments, too.
yeah, write that in the comments. And I bought a bunch of these pendants, so we're going to make more of them with each of our sand samples. The problem is the sand...
has to be very fine to fit in there.
You actually pour it through there. This is glued on. I don't know how they do it, whether it's glue or necessarily, but that's attached to the glass globule. And then there's this is a screw top up here and has a little tiny hole. And you have to pour the sand through the little tiny hole. Luckily, I have a little tiny funnel that worked perfectly. But it's not going to take that, it's not going to take any of those biogenics that we saw last week. So we'll just do it with sand, and I would like to predict for you what I'm going to do next week, but I don't know. I won't know until this weekend. I'll look at it this weekend to see if any of this works. Okay, so giveaway, pendant today. We'll give it away next Wednesday, and all you have to do is make a comment on today's video. All right? So let's go forward with this. So the area that we're talking about is here in southern New Mexico. That blue spot is where Shelley and I are, up in the Albuquerque area. This area is about a 3-hour drive from us. It's about 158 miles as the crow flies, but a 3-hour drive. I literally have not been there since I was a child. We used to go there every summer because we take those plastic snow...
sleds?
But they're the round ones. There's a name for them. The round snow sleds.
Okay. I don't know what they're called.
Discs, snow discs.
Okay.
And we would ride them in the sand. We'd stay in Alamagordo. We'd make a long weekend of it. It was
we had a picture of Jared on an inner tube or something going down and took a picture of him, and it was summertime.
Yeah.
And then Kevin had it printed out and put in a frame, and he had it on his desk at work in Dallas, and people would see it, and they'd ask him about it. They're like, "Why is your child out in the snow in shorts and a T-shirt? Isn't he cold?"
Yeah, because it does look like that. We're going to see some.
It wasn't snow.
We're going to see some photographs, but if you find yourself in New Mexico, it is just an outstandingly beautiful area, and it's worth a visit. I've made myself a promise after doing all of this research that I was going to go back this summer and get some great photographs. The photography is amazing. So the area that we're checking out here again, we're up here in Albuquerque. I-25 goes down in this direction. That's the Rio Grande, right? These are the San Andres Mountains. And then there's the Tularosa Basin is where the White Sands National Monument is. And if you look at it, what's interesting about this image is it looks like I got this off Google Earth, and it looks as if Google Earth had made it a point to kind of blur this area out. And the reason they blurred that area out is this area kind of north of this line is the White Sands Missile Range. And so technically they're not supposed to be able to see it. The Ruskies and the Chinese can't see it. So this is the national park down here.
But they have their own satellites, so they can look
at
whatever they want to look at.
So this is the San Andres mountain range, and the gypsum comes down from the mountain range, and it settles in an area right here. And I'm going to show you another picture that gives you a little bit better idea of that. So here's the sun. Oh, that's not even very good, actually. All right, this is a little bit better. So these are the San Andres Mountains, and they contain the gypsum. The gypsum is washed out with the rains, and it travels down the mountainside to an area on the south and east corner, and it's referred to as Lucero Lake. Now, you got to remember, this is all in the Tularosa Basin, very flat, desert-like basin. But that the gypsum as it's washed down from the mountains, travels down through here and ends up in this depression called Lucero Lake. And if they wanted to see Lucero Lake as blue, you would have to watercolor that in on a map. Because, first of all, right after rain, it's kind of brownish. And then after that, the water either evaporates or sinks into the earth, leaving the gypsum on top, and it's the winds, and you can kind of see the effect of the winds blowing in all those directions. It's the winds that carry the gypsum from Lucero Lake into the white sands. And so if it wasn't for the gypsum in these mountains, and it wasn't for the fact that that gypsum had such a short trip, it's very fortunate. Otherwise, it would never have become White Sands National Monument. And the reason is, as I said, gypsum is primarily calcium on the Mohs scale, the scale of hardness of minerals. It's a 1.5 to 2. Quartz, which we have seen most of the time, that makes it all the way from the mountains down the rivers out into the ocean and then onto the beaches, is a Mohs scale 7.5, 7 to 7.5. Much harder, right under the corundums, and then of course diamond at 10. So that's why it could survive the trip. Gypsum could never survive the trip. We have a gypsum mine between Albuquerque and Santa Fe, just north of us, and they've been mining gypsum there as long as I can remember, as we traveled back and forth from Santa Fe to Albuquerque and vice versa. Even when I was a child, that gypsum mine was there. So these are some of the pictures. As you can see, it is bleached white, and you're going to see under the microscope why the microscope had so much trouble. It didn't know what to do with white balance or exposure or anything. It was just struggling. These are our infamous yucca plants. I have a couple out in my front yard. They grow very easily in the desert and in my front yard. It's a little broader picture, not a big one. Those are the San Andres. So this picture is taken towards the west. Those are the mountains in the background that provide all the gypsum that comes down into the sand dunes. There are depressions, and these do collect water, moisture, and that's where you'll find most of the foliage. If you take a look at that video, you'll be surprised at actually how much foliage is supported, how much natural foliage is supported in the area, just because it does collect some water. They do get rain. It's not like your traditional desert where it doesn't get rain. There are primitive camping areas in the sand dunes, so you can hike out one of the parking areas with a permit, and you can camp in the dunes for several days if you're a photographer.
Dry camping.
Dry camp. It is very dry camping. You got to take everything. You got to take your own water.
Primitive.
Right.
There's no potties. There's no water.
No potties, no water. Means you got to take your own potty, and you got to carry out your stuff with you.
Yep. But what's that? Happy birthday.
One of my daughters calling me.
So, but the dry camping, you can do it. If you sign up ahead of time, you can do it on the nights of a full moon, and that's extremely popular. So if you decide you want to do that, because the sand reflects the full moon, and it's very bright, so people just love to go there for those, and you have to sign up way in advance to be able to do that. So
and if you time it at a particular time of the year, and you use, say, photo pills tells you, based on where your location, exactly where the moon is going to rise, and if you can catch it on one of those days where the moon is rising over the San Andreas Mountains, it makes for a beautiful photograph, because it's almost a daylight exposure because of the sands. So the other thing is the sands at sunset, and that's what you're seeing here in this case, will start picking up the colors, the late afternoon colors of the sun, and you get that warm yellow and orange glow. So it is a beautiful place to visit. Here's the sample, literally. We haven't had a sample this white. I don't know. This is going to sound
sand.
racist.
Well, sugar sand. That's
the sugar sand.
The one from Texas.
New Jersey. Well, no, the
one Lisa sent us.
The one Lisa sent us, but it had a lot of other, and it was not. Yeah. It was not, perfectly shaped. It was organically shaped, and it had.
Do you know where this gypsum comes from? Where it originates from?
The mountains, right up the San Andreas Mountains. Mm-hmm. The rainwater washes it down, and then into. Did you not listen to my presentation?
Well, I guess I missed that part.
Oh, okay. You're probably paying attention to the room. So we are up to sample number 17 in our collection, and we've got quite the collection. So I can't say anything else. It's white. And because it's so damn white, also there's nothing in the way of magnetism. It literally is. It's been processed, basically, washed out of the mountains into Lucero Lake. It dries up, and then it blows as effectively as dust over the sand dunes. So it's not going to take anything of any weight.
No, Tony, this is 3 hours south of Albuquerque.
Yeah. And 4 hours south of Santa Fe.
Yeah.
So this is as good a picture as I could get out of the digital microscope, the one that I used to process the sand.
Probably too much light reflection.
Well, you'd think it was, but it's grainy because it increased the gain. It just didn't know what to do with it.
Yeah.
And these cameras are very sophisticated in terms of their lenses and their acceptance of lighting, but they're very unsophisticated in terms of control. So when we turn on this Logitech, I can control gain, white balance, everything. You cannot do anything with this. I had to put it into Photoshop to even get it to something that wasn't. This came out blue basically. I could, right? You can see some of the coloration over here. So I apologize for that, and you're gonna not much better. By the time I got it to the stereo microscope, it was a little bit better, but it was really difficult to focus just because it's a single color. This is on the. Let's see. That's the digital microscope. Maximum focus. You can see the grains; they're rounded on the edges, but they haven't paid the price. Not in the way that, say, quartz has as it flows down a river. This is straight off the mountain. That's the stereo microscope. So these two images came from the stereo microscope. But again, I couldn't correct the color on them. This is one credible photo I got off the polarizing microscope that's about the right color, but as you can see, some of the stuff in the background falls off to green. And I did find a couple of them. They're not like quartz. They're not sparkly like quartz is. They're kind of a flat white, as you'd expect gypsum to do. They are, for the most cases, transparent, but not transparent, but translucent. They're not as clear as quartz crystals either, so you don't get a lot of light reaction to them. But they are mixed. You can see the different colors that you see here actually represent the fact that there's additional minerals in them because they're reflecting the light back differently. So the other thing, I wanted to point out that we did, you're going to see us on the screen here for just a second, we did put all those links in here in the description box, and you'll be able to find those below. Okay, so let's go switch over to the microscope. Oh, I forgot to open the microscope app.
Microscope time.
Okay, so let me turn on the two microscopes. Oh, they're not even plugged in. What the?
Not plugged in.
Yeah. Not paying attention here. All right, give me a second.
Put attention, you fellow.
Put attention, you fellows. Okay, we got to plug these babies in because the cameras, what I mean by plugging in, is I'm connecting the digital cameras that sit on top of the microscopes into the computer through the USB port. And then as soon as they're logged in...
They like the green.
They like the green?
Yeah.
Yeah.
So it's like emeralds. It's just the lighting. It's not actually. Yeah. They're not actually green. They're white.
Yeah, they're white. The green is faked. The polarized. Not even the polarized light knew what to do with them. So let me switch over to. Let me open the microscope app, and we're going to change devices, and we're going to bring it. Okay, so you can see this is. I'm gonna pull it out.
They can't. They're looking at the green one, I think. Are you sure you're showing it?
Look at it. It's moving.
Okay. Okay, there it is.
Okay. So, literally, this is what I'm getting out of it, and I'll try and adjust the lighting a little bit to see if it comes out. But you can see what the camera does then is it tries to correct. And there's no way to control this. I don't have a way to control exposure.
Looks like salt.
Yeah, it does. It's almost, you would have a hard time convincing anyone that that this is white sands as opposed to you went in your kitchen and dumped a, salt container out onto
some coarse grain salt.
Yeah, exactly. So that's it. There is literally no other color associated with this, in terms of character. You know, you want to
really shakes loose all the extra stuff.
Yeah.
It's just white.
Yeah. Because the wind carries it. It's like the dunes. It's just carried by the winds.
Right.
Well, the winds won't carry that unless they're really blowing hard. They're not going to carry the heavier particles. So it doesn't get any of that. So when I zoom in closer, let's bring the zoom in. And honestly, as much as I hate to say this, it doesn't get much better. Now, what you're seeing, all that kind of waviness that you're seeing is it trying to figure out, the camera trying to figure out what to do with gain, because it's just not, it doesn't know what to do with it. It has nothing to compare it to. The gain is actually a measurement, as the camera's trying to figure out, of contrast, right? If I had something that was dark in there, it could figure out the contrast. But when everything is white, it has no idea what to do with it. So that's why kind of none of the photos came out as well as they did. But you can see in comparison to, I might be able, let me see if I can adjust the hue just a little bit. Bring out.
You get blue or you get yellow or you get reddish, purpley.
Yeah.
But that's about the only difference.
But that's it. And you can see what we can see. You may not be able to see it on the screen, but what we can see is the camera trying to figure out down here. I wish you could see it. Down here, you'll see these numbers jumping up and down on the screen, down in the lower right-hand corner. That's the camera trying to figure out what it's seeing and trying to make adjustments. And it's just running back and forth. It doesn't know what to do. So unfortunately, it doesn't make for the best of a sample.
So we're just going to look at the big pictures.
So we'll just go with the big pictures, and let me see if I can get that into focus just a little bit. And then it changes color.
Purple.
It goes hue. So
Violet.
That's what I was saying. I had some good news and I had some bad news. The good news is we're at a beautiful location in the beautiful state of New Mexico. The bad news is the digital cameras on the microscopes have no idea what to do with this. I'm going to switch over to the stereo microscope now, and you're going to see, what were you going to say? I'm sorry. That's what you were going to say, wasn't it?
Which microscope?
I'm gonna switch over to the polarizing microscope.
Oh, okay.
Did you see her response there? Like, no, that can't be right. That was very good. I'm impressed.
Oh boy, I'm so impressive. I know the difference between two microscopes.
Well, yeah, but you knew
is it this one or that?
What I said.
Oh boy.
Yeah, exactly.
What is that?
Yeah, that's what I'm trying to tell you there. Oh, why is that light on? It's the wrong light. There.
Oh, it's darkness.
Hang on.
Hello, darkness, my old friend.
All right, hang on. I got to put the polarizing.
Now it's white. Now it's green. What color is it? Ice cubes.
So this is as close as we get, and this is the polarized light, and it doesn't look like there's anything in the way of polarization. So let me see if I can. Nothing. This is the most the sample that I've examined with the least character ever. I got nothing for you guys.
We might as well be looking at snowflakes.
Yeah, exactly. Hang on. Let me see if we go over the edge.
They're all slushy now. They're all melting.
There's I think that's the one that I took the picture of earlier. So if I get a flat side, then it's not so bad, and you get some response to it when it's flat side up. And what you can assume just by the striations on this is there is some point at which this particular grain slid across another set of grains that were harder than it was before it got to where it was. And you can tell because of that depression right there, there was a hole in it, and that wasn't the one that dragged across those much harder. And because this Mohs scale is 1.5 to 2, almost anything this is going to drag over is going to put some sort of mark into it. One of the ways that you can check out the various Mohs scales, you know what? I'm going to move the Petri dish, see if I can move over to the edge and see if there's anything. Yeah, it doesn't.
It's obsidian.
Yeah, I got
charcoal. Looks like charcoal.
I got nothing here. Let's see. I can't.
No. Not going to work.
The minute I go off. So now here's what's interesting.
Shape.
Right? Interesting shape and more translucent than the others. But one of the things you will not see, let me get it a little bit more focused. So if we were looking at a grain of sand that was quartz at the same magnification, you would not see these drag mark striations. Those aren't natural to gypsum. Those are actually because it drags, and because it's so soft, it picks up all those scratches. A quartz crystal won't, unless the quartz crystal is drawn over rubies, emeralds, sapphires, or diamonds. It's not going to get a scratch in it. This picks up all the scratches as it's traveling, and that was the one characteristic that I noticed as I brought them out into the polarizing microscope, is that you can see those scratches. I call them striations, but you can see those scratches on almost
That's
all
a good
of
shot.
them. Yeah, that's not bad. I'll take that. That's about as good as it's going to get. Let's go back to that other one. Kind of wondering if that isn't a quartz crystal. It kind of snuck in there with the rest of the gist. Maybe it's just because it's just oddly shaped rather than the others. So there is a little bit of color in them, nowhere near, like I said, the color that we see in quartz crystals. But still, part of me has gotten, well, I think I've become accustomed to looking at a sand sample under the microscope and finding not only a certain amount of uniqueness, but a certain amount of character. And while this could be called unique in that it is, sand, but by the definition of size, it just doesn't seem to have a lot of the character some of the other samples that we've looked at so far. There's one sneaking back there in the background. So, I don't know. I feel like I've let you guys down. So
That's all right. They got a close look at it. I mean, you wouldn't know until you looked at it. Now they know.
now you know. So, and it's funny, of course, because the definition of sand from a geologist's perspective is based on their size, 0.65 to millimeters to 2.0 millimeters. While this certainly meets that definition in terms of size, it just doesn't have any of the other characteristics. And again, we're talking the difference between a calcium-based sand versus a silicon-based sand that we've seen so many times up until this point. Literally every other sand sample that we've seen, the last 16 samples, have been silicon oxides as opposed to calcium silica oxides. So it's primarily calcium, and that's where the softness comes from, and that's maybe why it's not quite as dynamic. I haven't gotten that far in my geology course, so.
Well, Alan says some of this effervescence looks like abalone shells, and I don't know if effervescence is the correct word.
Where did it come from?
Opalescence, I think is what he means.
Opalescence would be a good way to describe
Corey
it.
says 17 episodes in, and sand is still surprising. Love it.
Oh, great. So I should show Alan. So if you like the abalone shell, this is one of my watches, and I've taken to collecting watches that have the abalone shell face on them because it really is very good looking when you've used it in jewelry. It's one of the few times a man can wear what is effectively a piece of jewelry. I'm trying to find a better shot for you while you guys are... I got nothing.
That's as good as it gets.
That's about as good as it gets there. So let me just show you. We got a nice little...
Are they seeing it?
No, they're not. I'm going to switch over right now. I was looking for it. So here's one. I'll make sure that I actually I will spend some time with this, getting some shots that I can put into the album that are just a little bit better. And what's happening here is some of the light that's going through the grains of sand is actually reflecting off the petri dish behind it, because these aren't resting on other grains of sand. So the petri dish is picking up some of the color. So, but like everything else that I've done so far on this program, it was fun to process. It took me twice as long to get the images that I eventually got, as bad as they were. I had to work with it figuring out how I could trick the cameras on each of the digital the digital cameras on each of the microscopes into giving me something that was, at least usable. I belong to two Reddit groups, one the subreddit geology and the other the subreddit rockhounds. And in rockhounds, they will let you show what they call microspecimens of sand. And I've put a couple of up there and got a very good response from the rockhounds. These guys are big rock collectors, but they like the pictures. I don't think I'm going to put this one up because I don't think I could for some of the others, in comparison to some of the others that I put up there. I don't think this one flies as well. So I am going to do a couple of sand samples, of course, next week, and I will before I post them. Before I say anything about them, I will process them at least through the digital. So we use 3 different microscopes in doing this. We use an Pendant digital microscope, which is in my workshop, and then the 2 microscopes here, both made by Amscope, one a stereo microscope and the other polarizing microscope, and they're top-end microscopes. And the Pendant has an integrated digital 12 megapixel digital camera and an LED light. The stereo microscope has a 16 megapixel camera and a ring light. The polarizing microscope has a 41 pixel camera and its own light, because you have to have the polarized light. And none of those 3 could come up with a picture that I thought was like, oh, I'm going to make a print from that. There will be no giveaway prints from this sample, I can tell you that. It's
Tony says, Google X-ray crystallography.
X-ray crystallography.
But you have the little pendant with the white sand, which is pretty.
Yeah. So Shelley makes a good point. Although it didn't make for a great picture, it makes for a pretty nice little pendant. So. Yeah. So make sure if you want to win the pendant,
and it goes with anything because it's white, so right. You don't have to worry about it.
And if you're a gentleman, just make your comment, and that way you can give it to your lady. And I tried to do it so it looked elegant. I'm interested in doing. I bought all the pieces off of Amazon to assemble these, and I'm looking forward to some of our more interesting. So
they're all
sands.
handmade by Toby.
Handmade by Toby.
Pretty awesome. You should put a little card in there with it that says handmade by Toby, and they can sign it.
And so I'm looking forward to putting some more of our more colorful samples in there. Not that I don't mean to be picking on white sands. I'm going to go down there this summer and get some great photographs for us.
It's a great place to visit.
It is a great place to visit. Okay.
It's so different than anything else in the world.
It is about as different as it gets any place in the world.
Yeah. Well, hey, thanks for being here today, for all your great questions and comments in the chat room, and for all your birthday greetings for Toby. And hope that you'll stay with us in 20 minutes. We'll be on the softerside.live. Check that out. I'm going to have my business coaches there. Jim and Lucas will tell us all about how to grow a thriving thought leader business. And I hope that you'll be there to support me, because they're my coaches and I want to look good. So I hope you'll show up and ask some cogent questions. And for World Sand Project, I'm Shelley Carney.
And I'm Toby Younis. Thanks for joining us today. I don't feel like I've disappointed anyone. I think we did a credible job of presenting this particular sample and or specimen. But I might have tested it first and maybe just put up a series of photos instead of making a show out of it. But thank you for the birthday wishes. I appreciate it. I'm very happy having made it this far in life, and I'm actually having a lot of fun being here. So thanks for that, and thanks for joining us today.